Now, let's look at the second problem. In this problem, we changed very little. It's just the sign over here is changed. We changed plus sign to minus, and here too. So let's do the same thing. We're going to look at 3 sets of choices to see what kind of curves we're going to get when we set either z or x and y to constants. So let's look at the first one. If z is equal to c, a constant, then we move the constant to one side. In fact, there should be plus sign. And so are these over here, should be plus sign. Okay. And then we see that 4x squared minus y squared is equal to c plus 3. Now, what kind of curves we have? It depends on what the value c is. If c is equal to negative 3, we have 4x squared minus y squared is equal to 0. In fact, we know this is not a hyperbola. It's just a pair of straight lines because we can factor things out like this. 2x plus y is equal to 0. And then we have 2x minus y is equal to 0. And 2x plus y equal to 0. And in the xy coordinates, we have the following. We have, so let's say this is x, this is y. Then we have y is equal to 2x, like that. This is 1. And the other one is y is equal to negative 2x, symmetrical like this. This is 2x plus y is equal to 0. And this is 2x minus y is equal to 0. Now, if c is greater than negative 3, let's say, for example, c is equal to, let's say, 0, then we have something like this. 4x squared minus y squared is equal to 3. Now, what kind of curve we have over here? You see over here, if y is 0, then 4x squared is equal to 3, and x is going to be plus minus square root of 3/4. So we have 2 points, right? One point is over here, and one point is over here. And we know how hyperbolas look like. So what we're going to have over here, something like this. And these are the ones that when c is bigger than negative 3. What happens if c is less than negative 3? Let's say we have c is equal to negative 5. Then this is something we have. We have 4x squared minus y squared is equal to negative 2. And this time we have y values but no x values. If x is equal to 0, then we know y squared is equal to 2. Y is plus minus 2, root 2. So these are the ones we're going to have. Let me use a different color over here to indicate these are different sets. So what we have are these ones. And these ones. Okay. So these are the, in fact, these are the contours because we are using z value, right? These are the contours of the surface we have. And now let's try to see if we can actually graph the surface using these contours. Okay, and these c's over here, they are negative. These are z less than negative 3. And this one over here, z is bigger than negative 3. Okay, so let's give it a try. All right, so this is 1 over here. Let me switch back to the black one. So we're going to draw x and y and z. Okay, but these are different cross sections at different level. Okay, so when z is negative 3, we have just a cross like that. Not very easy to draw, but hopefully we can just visualize like that. And then when z is getting bigger, then we have these lines. That x direction, if you look at it over here, what we have to project it down, and this is y direction, this is x direction over here, and then we are going to have things along the x line, and things like this. But that's when z is getting bigger, so we have something like this. This one over here, and this one in the back, and then it's getting bigger over here, and then getting bigger like that. And then let's try the other direction. When z is smaller than -3, and then we also have hyperbolas, but these hyperbolas are going to cut the y-axis, so something like this. It's gonna go like this one over here, and in the back like this one over there, and getting, because it's further down, it's further downward. Okay, so this one over here is going up over here, and this one over here going down. This one, it doesn't look like really a nice curve, nice surface, but that's something we can see from the contours. Now, let's try another set of traces. It may actually show us a better picture of the surface. Okay, so let's try use x is equal to c. That means we're going to cut back and forth, right? But this time, because x is fixed, so x is equal to c, then we have z is equal to 4c squared minus y squared and plus 3. And that's negative y squared plus 4c squared plus 3. So these are parabolas opening downward. So, and when c gets bigger in either direction, when y is equal to 0, so that these parabolas, they are opening downward, but the peak point is increasing for different z. So let's give it a try. Okay, so now we have x is fixed. Let's first try x is equal to 0 to see what we have. And that's in the yz plane. Okay, so this is the one we have, z and y, and this is x. Okay, so when x is equal to 0, so we have something like this going downward. This is x is equal to negative y squared plus 3. When y is equal to 0, z is equal to 3. So it's over here, and then it goes downward. Okay, and then when x moves back and forth, this parabola over here is going to move up. So it's going to go up like this, and here also moving up like this, and here moving up like this. And that's the one we have. Okay. It's not very good looking, but let's try the last one to see if we can do better. This is still going to be, let's say y is equal to c. And then we have z is equal to 4x squared and minus c squared plus 3. And these are parabolas opening up. But when z increases, when y increases, this is y. When y increases, the tip of these parabolas is moving down. So that's what we're going to try. Again, We're going to first try when y is equal to 0, because that's the xz plane. This is z plane, this is x. So in the xz plane, let's try. And we're going to have z is equal to 4x squared plus 3. So that's going to be over here. This is 3, and this is like that. Okay. But when y increases, this curve goes down over here, goes down. And the other side also goes down and goes down like that. It's not a very nice looking either. I think probably the better one is still number 2. Okay. So what we see is like a ridge, but in the middle actually is lower. And that's what we have over there. In fact, the best way is to combine the x and y, these cross sections. Let x is a constant and x is a constant. Let's try this one over here. Okay. So we're going to try to do this one over here. So in the x z plane, we have something like this, right? This point over here is 3. But in the yz plane, we're going to have something like this. Okay. And then we're going to try to move along this line over here. So these are going to be the x z ones, and like that, and like that. Okay, that's actually the number 2 over here. Okay. All right, and this curve, this surface over here, is called a saddle. This is called a saddle. Okay. And it's also called hyperbolic. I think this hyperbolic paraboloid. This is called hyperbolic paraboloid. The first one we looked at was the elliptic paraboloid. Okay. So when we don't have z squared, when we have a z, we always have a paraboloid, either elliptic or hyperbolic.